Good afternoon, everyone. I am Mr. H. Thank you for joining me. I am presenting to you in this video a favorite style of questions which testers like to ask of students. Test takers will frequently see these type of questions when it comes to logarithmic properties. You are given a bit of information. From that information, you have to then determine your answers to the questions that are provided. The information that I am providing you as if you were taking this exam is this two separate items. Log base a 3 is equal to x, log base a 5 is equal to y, and then based on those two items you have to then determine these, and these will require the involvement of logarithmic properties. You have to determine log a base a of 15, and you know what you're looking here in terms of 15. You're looking here at log base a 3 times 5. If you were to separate this out, you have a product here in terms of a common log. When you separate a common log which is in a product relationship, it opens up as a sum, as a plus in there of their individual logs. Now look over here, you know log base a 3 is equal to x, and then log base a 5 is equal to y, and this right here would be your representation, which would represent a suitable answer. This right here would actually be your answer. Log base a 15 based on these relationships is equal to x plus y, and these are the type of questions which you need to be inherently familiar with. We'll look in this video at a couple more of these style of questions. The next one you want to look at is this log base a 25. You know 25 is coming from here. You're looking at something which looks like this, log base a 5 but then square. And now utilize the properties of logs. This square is really a coefficient in terms of this log right here. You know what log a5 represents. It represents a y, but then there's a 2 before it, so your answer would be 2y. And this right here would represent the answer you would provide if given this as your question. Let's keep doing some more of these practice style of questions because you have to be comfortable with these style of questions. Now we have log base a of 45. 45 can come from a combination of these two numbers you have. Think of it as this way. You're looking at log base a 9 times 5. But then you know you're also looking at this log base a 3 squared times 5. And now you have a product here in terms of their common logs which can separate in terms of a sum of their individual logs. You would have log base a 3 squared plus log base a 5. This 2 can come right over here. You're really looking at now 2 log base a 3 plus log base a 5. You know log base a 3 in all instances is equal to x, but there's a 2 before it, so your answer is 2x, and then here you have a 5 which is represented by y, and then here 2x plus y would represent the answer to this question right over here. And now you're kind of getting the idea of how these type of questions are handled. Our question is this log base a 0.6. Now you know 0.6 is coming, if you are thinking 3 and 5, it's coming really from log base a 3 over 5. You take your calculator and you do 3 divided by 5 and you'll get 0.6. But here you have a common log with regards to a quotient. When you have a common log with regards to a quotient, you separate them into their individual logs, you bring a difference into the formula, and you'll have log base a 3 minus log base a 5, and you know this is equal to x, that's equal to y, so you have x minus y representing the answer you need to provide for this question, 0.6. Let's look at this log base a 25 over 9. I'm purposely not putting this in a decimal format because when you're dividing things by 9, if the item is not a multiple, you get repeating decimals, so we can keep it as this. When you're looking at this, it's kind of a giveaway. You're looking here at a quotient in terms of a common log, which means then you're looking here in terms of an individual logs as their difference. You're looking at this log base a 25 minus log base a 9, but each of these is coming from the square of that. You're looking here at a log base a 5 square minus log base a 3 square, which by means of properties of logs, these exponents coming out as coefficients are equal to 2 log base a 5 minus 2 log base a 3. This is equal to a y, this is equal to x, but then you'll have a 2y minus 2x, and this would be the answer you would provide. And now we should be getting quite comfortable with these style of questions. Therefore, I'll present you a single other question and we can end the video with that. When we're looking at this, we're looking here log base a 3 over 25. This common log with a quotient is equal to the individual difference of their logs, and you're seeing it come out in this form right here. Log base a 3 minus log base a 25, which you know that is coming from a square of a log base a 5 square, which again, as you know now, is equal to minus 2 log base a 5. Now you know this right here is equal to x, but this right here is equal to a 2y. So x minus 2y would represent the answer to this specific expression over here, and it would be right. So now always keep in mind, when you're looking here at some, let's just say in terms of a log and a base over here, I'm ignoring the base. When you're looking at it, you're looking here in terms of opening them up as a sum of their logs. When you're looking here at a quotient, you're opening it up, you're looking at a difference of their logs. And in all instances, you always remember this. Anytime you have something like this, an exponent, it can come down and travel as a coefficient, and that would be how you would deal with something like that. But that's it for this particular video. These are the properties of logs which you are seeing in this video, these three coming into view in this form, and this type of question is very common on standardized exams. Thank you for watching. Have a good day.